Hello friends, today we are going to learn a most interesting and important topic of textiles in which we study about the primary properties of textile fibers. The properties or characteristics which speaks about specific fibers, that why fiber reacts like this in a particular situation when they are under stress, when different finishes are given to the fiber, when different treatments are given to the fiber. So we will study primary properties of textile fibers in detail. So let us start with the topic. The textile fibers are either produced from the nature, and we know that, right? Or either they are produced through a series of chemical reactions as synthetic or man-made fibers are produced. So a large variety of fabrics are there in the market which are manufactured or processed according to the usage. For example, if I want to have a jacket, a firefighter jacket, I need to have some properties like high tensile strength, thermal resistance, etc. So the particular fabric which I am searching in the market should have those properties if I want to use that jacket as a firefighter. So different fibers are made according to the purpose for which they need to be used. So they should have that particular primary and secondary properties, right? So we will move towards the primary and secondary properties. We'll learn what are the primary and secondary properties. So primary properties or essential properties are those properties that the textile must possess in order to being processed as a textile material. It means they have to pass through some test. The fibers have to pass through some test in order to convert it into a textile. So these are all the primary properties which fibers need to be tested. So first property in this series is higher length to width ratio. For any fiber to be spun, made to yarn and then into the fabrics, is that their length must be more than their width. The minimum length to width ratio is 100:1. Means the fiber needs to be longer than the wider. The length of the fiber is also on the basis for classifying them into the groups of staple or filament yarns. Staple fibers are short length fibers generally obtained from the natural sources like cotton, wool. Silk is not a staple fiber. Silk is a filament fiber because the length of the fiber is long. The width of the fiber refers to the diameter. This is measured in microns and determines the fineness of the fabric or fiber. A point to note here is that the diameter of the synthetic fiber depends upon the spindle hole from which the liquid passes out and it is converted into yarns. Next property we have tenacity. So what do we mean by tenacity? Tenacity is also referred to as strength of the textile fiber. It is the force required to break the fiber. The force which is required to break the fiber into 2 or 3 parts, that is tenacity. The strength is basically classified into 3 types on the basis of force direction of tensile strength, tear strength and bursting strength. Each fiber must possess a certain amount of strength to be able to bear the mechanical and chemical processing that it undergoes during the manufacturing process. When determining the tenacity of fiber, it helps us to understand how the fabric will bear both dry and wet conditions. For example, cotton is stronger as when it is wet compared. It is weak when it is wet. Next property we have flexibility. A fiber should be flexible because it needs to be plied is in order for it to be made into yarns and thereafter into the fabric. Certain products require a fabric that is flexible. One such example is automobile seat covers, belts, elastic fibers. So the property here shows that if certain fibers that are composed of wood, but these do not find application in the industrial textile due to lack of flexibility, while materials made from glass or metallic fibers possess low elasticity and are stiffer, ruling them out to be used in the apparel sector. So according to the flexibility, the usage is different. Next property we have spinning quality or cohesiveness. Cohesiveness is the property of the fiber to adhere to each other during the yarn manufacturing process. When we are spinning the fibers, when we are twisting the fibers to make the yarn, the spinning quality or cohesiveness matters, that the fiber attaches itself with the other to convert the fibers into a long strand of yarns. The process of spinning makes the fiber surface resistant to friction, and it is the lack of mobility that enables the fiber to stick together when being spun into yarns. There are some inherent irregularities in longitudinal or cross section of the natural fibers which permit them to hold to each other during the fiber arrangement. Wool, for instance, has an inherent crimp and scales on its surface that imparts a high degree of cohesiveness. As we will see in the wool structure when we will study the manufacturing of wool, we will see to it. And in the case of synthetic fibers, it is a long length of fiber that brings cohesiveness. So, cohesiveness is the quality of spinning, twisting the fibers to convert them into yarns and then into fabrics. Next we have uniformity. Uniformity is an important property of fiber because it is even yarns that fabric uniform in appearance and consistent performance. As we have studied polymerization, here we have studied the structural arrangement of monomers, polymers, so the arrangement, the uniformity of the fiber matters a lot in the fabric structure. So uniformity is also associated with strength and other properties such as uniformity in length and thickness. The natural fibers are since procured from natural sources such as sheep hair, silkworm, seed hairs, etc. These are subjected to differ from each other in length, thickness or quality. For instance, wool fibers sheared from the sheep has various grades depending on the area from which the wool is taken. For example, the wool taken from the lower leg area or underbelly is not of the high quality. So all these things matters with the quality of the fiber. So today we have studied the properties of the fiber, different primary properties of the fiber which are necessary to be a part of the fiber if we need to change that fiber into the textile fiber. So that's it for today. We will meet again with an interesting topic in the next class. Bye bye. Take care.